I hope everyone's having a great day. I am Mr. Ish. Thank you for joining me. We have to show that angle A is equal to angle B. We have this representation here before us. This right here is angle A and that right here is angle B. This segment BC is parallel to the x-axis. You also have the y-axis. And you know you're generating a 90 degree here. With the x and the y-axis, you're generating a 90 degree here. Therefore, that's 90, and that's 90. You have a 90 degree angle over here between the origin and this B, and to that end we can call this D. We have a 90 degrees generating here. How can you go about showing angle A is equal to angle B? I'll show you. You have to make a very good assumption here from the very start because there's no numerical items involved in terms of actual specific angles. If this from right here to here is equal to a certain rotation and that rotation is called theta, you can easily figure out angle A. Because angle A would be the difference between this theta and this 90 degrees. You know angle A over here is equal to theta minus 90 degrees. We'll keep everything here with regards to degrees, not radians. Consider again, you have this 90 degree between your x and your y-axis, then you have this A. Theta is equal to the sum of those two, therefore A is equal to theta minus 90. If you look at this triangle right here, this large triangle, if we call this right here E, we call this O. Now I'm talking about triangle OBE. That triangle OBE. And I draw it out over here. We have a 90 degree. We have this angle right here, which is angle A, theta minus 90. We can find out that angle. The sum of the internal angles of a triangle are always equal to 180. We'll have theta minus 90 plus 90, which is this, plus that certain angle x is equal to 180. And then you solve for x. X here is equal to 180 minus theta. And that'll be that angle right there. But that angle right there will correspond to this angle right over here. And that's 180 minus theta. So that has been done for us. So we've made some very good progress over here, because we're not too far away now from determining the angle B. We know that A is equal to theta minus 90. Now let's look at this small triangle right over here. Let me call this point F. We're now looking at BFE. When I take BFE and I pluck it out, and you know this right here is part of a larger triangle BCD, but that entire triangle BCD is irrelevant. We're only looking at BFE. B, F, and E. Right here is my angle B, which I need to determine. Here happens to be a 90 degrees, and here we've determined not too long ago is this 180 minus theta. And now we can easily solve for B. B plus 90 degrees, which is this, plus 180 minus theta is equal to the total internal sum of angles is 180. This cancels out with that, and you can solve for B. B is equal to, you take everything on the other side, theta minus 90. And that exactly was theta minus 90 for A. So we've shown you this is equal to A, this here is equal to B, therefore A is indeed equal to B. An interesting fact will be that this B represents the angle of this large triangle BCD. If you look at everything over here, you'll find out some very interesting fact over here. If you look at this large triangle BCD, we're calling that a triangle BCD. And we're looking at this triangle BFE, that triangle, and we look at this triangle right over here. We'll call that triangle OFB. These all triangles are similar triangles. They'll all have the same angles. Think about it. You have a 90 degrees, you have a 90 degrees, you have a 90 degrees. You have a theta minus 90, you'll have a theta minus 90 for the small triangle and theta minus 90 for the same large triangle which shares the common vertex. And everything else will be exactly what you would find it to be. All of the other angles right here, this 180 minus theta over here would be a corresponding 180 minus theta, exactly as you see it, 180 minus theta, 180 minus theta. The only thing which then remains is to do is determine that, and you can easily do that, and that should be 180 minus theta, and I'll show it to you very quickly. You have an A, you have a 90, and then you'll have an, we'll call that a Y. A, which here happens to be theta minus 90 plus a 90 plus that y, we'll call this angle y, is equal to 180. These cancel out. Y is equal to 180 minus theta, and that happens to be right here, 180 minus theta. So each of these similar triangles has a 90 degrees, it has 180 minus theta, and has a theta minus 90 in terms of their representations for the three internal angles. Therefore, each of these triangles is a similar triangle. Again, the triangles are OFB, BFE, and then BCD. And that's it for this video. Thank you for watching. Have a good day.